So, all right, in this today's workshop, we will begin with the fundamentals as requested by majority of them. Okay. And what we will do is in today's workshop, we will begin with the fundamentals, as I told you, right? We will begin with the fundamentals, ensuring that everyone has a solid understanding of the basics. From there, we will gradually move toward implementing MLOps step by step, covering key concepts, best practices, and real world applications. So our goal is to make this an interactive and hands-on session. So feel free to ask questions and participate actively. All right, let's get started now. Since we have requests from many beginners in the past session and now, right, so we will start by understanding the fundamentals of machine learning, what it is and why it is important. Once you have the basic understanding, I will walk you through a simple demo of a machine learning model using the linear regression algorithm so that you can see how machine learning works in action. After that, we will explore the machine learning life cycle, which is crucial for understanding how machine learning models are built, trained, and deployed. This is very much important. Okay. If you say you're a data scientist or a beginner, definitely you should be knowing it, what exactly the machine learning life cycle, what are the stages involved as part of the machine learning life cycle. You should be aware of it. Okay. Then we will dive into the core of today's session, the MLOps. What is MLOps? Why do we need MLOps? The key difference between DevOps and MLOps. Once you have clarity on that, we will move ahead and discuss the traditional model deployment, the challenges it presents, and how MLOps helps overcome them. Finally, we will explore MLOps level 1, and if possible, we will continue with level 2 also, because I will give you a demo in a Jupyter Notebook, how to train a model, simple machine learning model, so that you will have an understanding about what exactly the how exactly the machine learning model works. Okay. So only when you see that demo session in Jupyter Notebook or the script, right? How do we train the model? How do we apply the trained model on the unseen data to make a prediction? You will get a complete understanding about how the machine learning model works. Okay. Okay. Next, we will jump into understanding the basics of machine learning. Okay. What is machine learning? What is machine learning? To understand what is machine learning, let's start with a simple real life example. So in here you can see that, right? He is Raj. This gentleman name is Raj. He wants to buy a car. He wants to buy a car, but he needs a loan from, let's say, XYZ bank. So what he does is he fills out a loan application and he meets the bank manager, Mr. John. Now the question is, how does the bank decide to approve his car loan or reject it? That is what the question. So as soon as he submit the loan application form, they cannot approve the car loan, blindly by closing their eyes. Okay. The typical process, they need to go through the application form and see his income, pre-existing loans and credit score, and so on. To checking the credit score, it will take time, and checking the pre-existing loans and other, other EMI commitments, whatever he has, it will take time. Apart from this, not only Raj, this gentleman, okay, like him, many customers have applied for the loan. Okay, the bank received, like Raj, right? The bank receives thousands of applications every day. The challenge here is manually checking each and every application would take forever. So banks want to learn. Banks want to learn, or sorry, banks want to rely on machine learning model to make smart predictions, because the machine learning models can make predictions in a matter of minute or so, even for 100,000 customers. 100,000 customers loan applications. Okay, all you need to do is just apply the trained machine learning model on the 100,000 new customers, those applied for the loan. It will make a prediction in a matter of few minutes whether they are eligible for loan or not. Okay, how it is possible? Okay, so what the banks, right, they do it to enable their machine learning model to make a prediction, automated prediction. They take the past data, something like the previously those customers they obtained for loan, right? So they took their past data like income, credit score, existing loans, loan paid back, all these data. They take it, they collect the data. The first step is collect the data, and then they need to take this collected data and train the machine learning model. What you see in the middle is this is your machine learning model. This is your machine learning model. Okay, fine. This is your machine learning model. So here the machine learning model, what we are doing is we are training the model with this past data, which is nothing but the historical data. The model, what it does is once it get trained with this historical data, it learns the pattern from this data set automatically. That is the beauty of using the machine learning model. It automatically extract the pattern from this data set. Forget about machine learning model. Let's say if I ask you by looking at this data, what what patterns that you can infer from this. Obviously, you can tell very quickly. So this customer, right, his credit score is 800, his credit score is 750, and he has no pre-existing loans. Yes, in the past we approved for these kind of customers, and then they paid back the loan also. Whereas this customer, if you see this, his income is also less, and his credit score is less, and he has a pre-existing loans, hence he was not able to pay back the loan. If I approve people with this characteristics or with this data, right, with this background, what will happen? They may not be able to repay the loan. This is what we infer from this. Like how we can infer the pattern from this data, the machine learning model also extract the pattern automatically while learning the historical data. While it is being trained by the training data, right? Or the past historical data, it extract the pattern automatically. But machine learning is much more powerful. It can learn more patterns than the normal human can extract. Okay, this is a simple data. Even with the complex data, the models, the machine learning models or AI models can learn even the complex patterns in a matter of few seconds or minutes. Okay, now the model learned these patterns. What pattern was learned by this model? High credit score led to higher chance of repayment. And existing unpaid loans. For example, here unpaid loans. This guy, did not make any payment. Okay, and in this case, existing unpaid loans. This guy, this borrower is a risky borrower. Okay, and then stable income equal to more likely to pay back. Okay, stable income equal to more likely to pay back. So in this case, and in the sense, right, higher income, they are more likely to pay back, and then there are no loan commitments. See here, okay, there is a question from Edward. He's asking, what if there is not any credit score and no existing loans? So that we will discuss it later. Okay. So at this moment, please try to understand how the machine learning, what exactly the machine learning model is all about. How does it works? So what we are doing is, in this case, the machine learning model, we are training this with the historical data. Once it gets trained, it learns, it extracts the patterns automatically. Okay. Now the question is, okay, a new customer by the name of Raj, who applied for the loan. Here are is the background. Okay, so his financial background, so income, and credit score and existing loans. So obviously you need to fill out all these details in your um, loan application. Okay. So in this case, obviously, right, with your PAN card, they can find out easily what is your credit score. Okay. So in that case, obviously, credit score is also one of the important parameter, right, to determine whether you are eligible for loan or not. Fine. But still, right. So here what happens? Okay. So now what happens? This since this customer is a new customer for the bank XYZ, what they do is simply they apply this trained model on this new customer's loan application data. But forget about the model. Okay, if I ask you, you have already learned the pattern from this data. So do you think the new customer Raj is eligible for car loan? Is he eligible for car loan? Prabal Srivatsa. Okay, I'm a fresher learning AWS. Okay, very good. How about Sri Krishna? Sri Krishna and Kritika. So you just look at this one, right? His credit score is 720. Am I correct? Yes. 720. As his income is 60,000, he has no existing loans. Obviously, he is eligible for car loan. How? Because the model already learned the pattern. Look here, it applies the pattern on this data. So high credit score, yes, 720. Above 600 or above 700 is high credit score. High chance of repaying. Existing unpaid loans, risky borrower, but does he have any existing loans? Nothing, right? And his income is more compared to this one 50,000 70,000, right? His income is more, hence he is eligible for loan. So, right, the way how we interpret manually, similarly the machine learning model has a capability to extract the pattern automatically when you train the model with the historical data, and once you apply the trained model on the unseen data, the new data, it makes the prediction automatically. Here what are the steps involved? You need a historical data, you need to collect the data, historical data, and then you need to train the model extract the pattern automatically from this trained data, and then when you apply this model on the unseen data, the new data, it makes the prediction automatically, right? So here what happens, since Raj's credit score is good and he has no existing car loan, the machine learning model predicts that he will repay, so the bank approves his loan. Okay, you might be asking this question: if credit score is the only determining criteria, why should I need a machine learning all the thing? You have received so many loan applications. To make this concept simple, I have used a very simple data here. So here we have only three columns are there, right? So three or four, three columns, three plus one, four columns are there. But in the loan application form, if you see so many so many plain columns, you need to fill it out in the online. Okay, and again to processing all the loan applications, for example 100,000 loan applications in a matter of few minutes, it is practically impossible by human. And that too, right, if you do it, if you want to do it, you need more number of staffs. And also, if you want to complete it, if you want to approve it, or if you want to make the decision, you might tend to make some mistakes. Okay, maybe you may approve the loan for the wrong customer, right? So in this case, yes, machine learning model. If you train them with the historical data, and if you apply the train model on unseen data, the new data, it makes the prediction without writing any program explicitly. Okay, so now predictable. Raj applies for loan. His data is this one. Since Raj's credit score is good and he has no existing loan, the machine learning model predicts that he will repay. So now the bank approves his loan. Okay, so this is how the machine learning model works. What is that? How? What are the steps involved here? You need to have the data. You need to extract the historical data. With that historical data, you need to train your model. Once you train your model, you apply the train model on the new data. So that with that trained model, whatever the pattern it learns, that is an experience. It applies the experience on the new person's data, and then the model gives the predicted output. What is the predicted output in this case? The model says yes. Yes means he is eligible. The model will predict either yes or no. So in this case, the model will predict yes. Okay. So this is how the machine learning model works. It's very simple. Is it clear? Is it clear or not? So what is the definition for machine learning? The same thing. We train the model with the historical data. Once the model gets trained with the historical data, you apply the trained model on the unseen data to make a predictions without explicitly writing program. What do you mean by without writing explicitly the program? Because here you have given the input as the historical data. That's all. The model automatically learns the pattern, and then you apply the model, the learned model on the unseen or the new data. It makes the prediction automatically. Did you write any program here? Nothing. But to train the model with this data, you need to write code. But the prediction, extracting the pattern, and all, you did not write any rule-based coding, right? If you don't have machine learning model, what you have to do? You need to write a lot of rules, right? If the income is this and the credit score is this one and the existing loans are no, then he is not eligible. Again, you need to write so many ifs and if and else loops, right? And loops you need to write it. Nested ifs you need to write it. Rule based. Here there is no rule based programming here, but instead we just train the model. We just simply show the historical data to the model. The model can automatically, like the way when you see the data, you can extract the pattern. Similarly, the model has the capability to learn the pattern automatically. Someone had already invented these algorithms. Okay, hence it doesn't require too much of programming to extract the pattern. Is it clear? So this is what machine learning model is all about. Next, what we'll do is we'll proceed with understanding the machine learning life cycle. What is machine learning life cycle? Anybody has any idea? Okay, since most of you are not familiar with the this topic, right? So what is machine learning life cycle? Like human being has life cycle. Like for from the so let's say a kid born, like a human born, right from birth to adulthood and adulthood to retirement, there is a life cycle. Similarly, when it comes to machine learning life cycle, there are different stages are there. The first one is the problem definition. Okay, so problem definition. The first stage is the problem definition. The next stage is the data collection. So what do you mean by problem definition here? Problem definition is something like what purpose we need to develop the model. Is something like what is the purpose of a human? See, every human is born with a purpose, right? Maybe to become a doctor, an engineer, or a teacher. Similarly, in machine learning, the first step is defining a problem. For example, we want to predict whether a customer will churn from a telecom service. What do you mean by churn? Whether a customer is going to leave my business or not. What are the chances that my existing customers might walk out from me? Okay, so after the customer leave your business, if you run after them, it doesn't make any sense. Before even if you have a mechanism to predict which all existing customers are more likely to move out of my business, if you know well ahead, you can talk to those customers, the risky customers, those are about to leave your business well ahead. You can find out from there what is their problem, why are they not purchasing the way how they used to purchase, why are they not renewing their subscription? While talking to the customer, you will get to know their concerns. Okay, and then if you address their concerns on time, it's also high that the customer will stay back with you. So you need to first define for what purpose you want to build a model, machine learning model. There is a clear cut purpose here. Okay, you need to define it very clearly. Why you need to define a model? Why do you need to develop a model here? Next step is the data collection and extract the exploratory data analysis. What is data collection? So once you define the problem statement, what you are going to solve, okay, why you are going to develop the machine learning model, the next step is, yeah, we need to collect the data, gather the relevant data for training and evaluation, and then the quality and quantity are also important, right, for the success of the model. And what you do is you explore the data. Once you have collected the data, explore the data and see what patterns you can find out from the data. And also find out, are there any issues with the existing data in terms of missing values, or do you have any redundant data available? Redundant features are available. Features are nothing but columns. In machine learning world, we call the columns as a features. Okay. And the next step is, once you identify the problems in your data, right? So what you do is you do the data pre-processing. So what do you mean by data pre-processing? You clean the data by handling the missing values. In case of any outliers or inconsistencies, you need to first fix it. Any data related issues, you need to fix it. Because only when you give the good quality of the data to train your model prediction accuracy will be good. Your model accuracy will be more reliable. Okay. So hence you do the data cleaning, everything as part of your data pre-processing. And the next step is feature engineering. As part of feature engineering, what we do? What is the difference between pre-processing and feature engineering? The previous session I discussed about Srivatsa. I discussed about, you were there in the previous session, right? What is the difference between pre-processing and here we do the data cleaning. Here what we are doing is we are creating new features with nothing but the new columns. If I say feature, it is nothing but a column. We are creating a new column based on the existing column. What do you mean by creating the new column based on the existing column? Give me an example. For example, you have a column or the feature by the name of age, right? You have the column by the name of age. So in the age, you will have the numeric value like 25, 16, 17, 30, 35, 45, 57, something like that. But you want to have an additional column, you want to create a new column based on this column age. Why? Because we wanted to classify the data based on their age group. So we classify those customers ages are between 13 to, let's 13 to 19 or teenagers. You want to put a text in the new column wherein we are going to specify all the teenagers as teenager, and then young customers, right? For them we put young customer, young teenagers, young, very young, and middle age and old age, older people. Okay, so that later point in time, if you want to do some kind of analysis, how many number of uh, uh, orders we received from the teenagers for a specific product, and uh, of all these age group, which age group of people spent more? To do those kind of analysis, we need an additional feature called age group. Okay, so that age group column we derived based on the existing age column. This is a simple example for age group. Okay, this is called feature engineering. Feature engineering is create new features from the existing data set to from the existing data set. This is to improve the model performance. Sometimes what will happen is you train your model with the existing features. You will not be right, so the model performance is not up to the mark. Probably if you add an additional feature that might improve your model's performance. For that reason also, we add the additional features, but you need to be cautious. Just because I told you, simply don't add as many columns as possible, but only when you see that model, well, you need to decide whether adding a new feature is going to help me to do exhaustive data analysis. From the data analysis point of view. From the machine learning point of view, will that add any value in terms of improving my model performance? By keeping in mind of these things, you need to do the feature engineering. Next step is feature selection. Okay, what is feature selection? Choose important features. Okay, you need to choose the important features that can help or boost your model's accuracy. By adding the features that are not going to add value to your model performance, right? You need to be bit cautious about this. Okay, just because I have 100 input features are there, blindly don't train your model. You need to choose which features are really helpful in terms of boosting your model accuracy. The classic example is, I want to predict the housing price. I want to predict the housing price. What factors can drive the housing price, or what factors can influence the housing price? The size of the house, square feet, size in terms of square feet. Next one, the age of the house, location of the house. These are the factors can, and let's you have something like the customer's contact number is there in the data set. His email ID is there. Does email ID or contact number helpful in terms of predicting your housing price? No way. In that case, you need to drop those kind of features. Don't include those kind of features. If you include those kind of features along with the features that are more important to predict your target outcome variable, what will happen is it will add noise to your model training data. So noise in the sense in a kind of error. Okay, the model accuracy will not be good. Okay, so the feature selection involves choosing the important features. Okay, choosing the important features are fine. How do I know which features that I need to? In the case of housing, predicting the housing price, fine. So I can use my common sense or domain expertise. I can determine what features can be helpful in terms of predicting my housing price. Fine. Are there any tools that are available? So there are some certain things, right? Customer churn. In the case of customer churn, you want to predict whether the customer is going to leave your business or not. Yes or no. If yes means, if your model predicts yes, those customers are more likely to leave your business. And you have various columns are available. Okay, various input features are there. So in that case, it will be difficult to decide what features are important to predict my customer churn. So in that kind of situation, there are techniques that are available. You have something called lasso, LASSO, and SHAP, 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 lasso, and other statistical methods are helpful in terms of if you do the feature selection. The feature selection technique, what it does is it'll include only the features that are helpful in terms of predicting your output variable, which in the case of housing price. Yes, it'll keep only the relevant features automatically, right? It'll help you, or it will help you to show this. Hey, keep these features in your model. Rest of them don't include it. Discard those features. Okay, based on the suggestion provided by Lasso and SHAP, you can decide what features that needs to be included, what features that are not at all required. You can eliminate it. Okay, for that, what tools you can use it? You can use something like SHAP and mutual information, and you have something called scikit-learn. Scikit-learn is the important package that is available in Python to train your machine learning model. Okay, okay, fine. So once you are done with the feature selection, the next step is you need to do the model selection. What do you mean by model selection? See, a lot of models are available. So to predict the housing price, in the case of machine learning, you have various algorithms are available, like linear regression, decision tree, random forest, XGBoost. Likewise, you have more number of machine learning algorithms are there to predict the housing price. You need to choose the appropriate model. Okay, so it's kind of a trial and error, hit and miss. What you do is, right, you need to first start with some model. For example, let's say, you start with random forest model, and then what you do is you choose the random forest machine learning model, and then you train your model with this data, and then what you do is you tune your model. So training the model is not sufficient. It's something like you want to buy a car. Which car you want to buy it? First you select it, right? And then what you do is, once you select the car of your taste, then you go for a trial run. That's called your model training. And then what you do when you go for a trial training, trial run, right? So you drive the car by applying, by turning the car left side and right side. You try various features. Okay, if it is not up to your expectation, what you do? You say, man, no, I'm not comfortable with this. Can you bring another car, different model? Similarly, here we start with some model and then kind of experiment. Okay, we select one model and then what we train the model, and then we do the hyperparameter tuning to see if this specific chosen model, can we do any parameter tuning even after tuning your model, if the perform, and then what, so you need to tune your model and then you check your model performance. Evaluation is kind of performance. You just think that way. If your model performance is not up to the mark, again you need to choose another model. Okay, let's say you have XGBoost, that algorithm is available. You take that model and then train that XGBoost model with this historical data, and then do the fine tuning and check the model performance. This is evaluation, nothing but metrics. There are some metrics specific to the machine learning models are available. Okay, with that metrics, you can measure your model accuracy. It's something like human. We have some, let's say, how do you say you're a healthy person? How does the doctor knows whether we are doing good or not? Our heart rate is a metrics. Blood pressure is the metrics. Sugar level is a metrics. Right? Everything has some reference level. If the heart rate is falling within this level, your heart is healthy. Similarly, when it comes to machine learning model, there are some metrics that are available. With that metrics, we will check whether this model metrics are on par with our expectation or something like that. Otherwise, so that's why I put this icon. This is an iterative machine learning life cycle is an iterative or iterative process. It's not a one-time job. You need to choose different models. Each model you need to train it and tune it and then check the model performance of all those which algorithm, machine learning model performs well. You need to, you need to check it. You need to find out that how do you figure it out based on the metrics, whichever models metrics. For example, we have something called accuracy. Okay, if the whichever model's accuracy is more, then you are good to go with deploy that model in the production system. Before you deploy the model, what you do is you create a user interface or you create some application so that the end users, they enter the data. For example, in the case of previously we discussed about loan. So they enter the, for example, you are a banker, right? So you enter the customers, specific customers' age and his income and credit score, pre-existing loans, you enter it. And then you just hit that predict button. It will display whether the customer is eligible for the loan or not. The predict button, when you hit it, the model will make a prediction and then it will say, hey, yes, this guy is eligible for loan, right? So to key in the features, you need to build the user interface. Okay, maybe, right, you might be asking this question. Hey, you said in a matter of a few seconds, even if I have 100,000 customers, they applied for the loan, it will predict it, right, within few minutes. Yes, that is possible, but interactive also, if you want to check it, that is also possible. For that, you can create the user interface using Grado or Streamlit, right? So with that, you can do it. And the bank manager can enter the details about the loan applicant. And then when he hit that predict button or something like that, it will make a prediction and say, yes, hey, this guy is eligible for loan. He can go ahead and approve his loan, right? Something like that. Okay. So that is also possible. Interactively also make a prediction. That is also possible. If you want to do that, you can create a user interface using some applications. Okay. And then you deploy the model. This is very critical. Once you deploy the model, it's something like, let's say your person you took a birth, and then he became adult, and then he went to the college and he studied. After study education, he has to go to the job. Going to job is, he has to go to a real world thing, right? Similarly, once you deploy your machine learning model in the production system, this model will be accessed by the end users. Okay, end users. So you yourself can check, right, the credit score. What is my credit score? If your credit score is good, then you are pretty much sure, yes, my credit score is really good, so I'm eligible for loan, right? So if your credit score is very poor or less than 600 or less than 600 as per India thing, right, you are not eligible for loan. Okay, so likewise, so the public themselves can go and check, right? So similarly, right, here once you deploy the model, your internal stakeholders can go ahead and key in the values, and they can get the output. Okay. And then once you deploy the model in the production system, it is highly important. This model needs to be monitored continuously. This is very specific to the machine learning models. Not only machine learning, even deep learning, or even the LLM models like ChatGPT, all things. You need to continuously monitor your model performance. The reason is over a period of time, because of the new data coming in, because new customers may order the product from your retail store, right? Their purchase pattern may be different from the past customers' purchase pattern. Your model got trained with the past customers' purchase patterns. What if the new customers' purchase patterns are different? If the new customers' purchase patterns are different from the previous customers or the past customers, obviously your model performance will fall down. It's your accuracy will fall down. If the model accuracy falls down, right, you will end up getting inaccurate predicted output, right? So what if your model predicts a good customer as a bad customer mistakenly? What will happen? You are going to lose that customer, right? If the model predicts the good customer as a good customer, then what you do is you can give some special offer to him. There is no point in giving the special offer, special discount to the customer who is going to leave your business, isn't it? So if your model accuracy is not good, it will drive you to make the wrong decision. Hence, you need to make sure that even after deploying the model, you are monitoring the model performance continuously. Okay. In case the model performance decays, you need to again, right, you need to retrain your model. Okay. You need to take the new data, right? You need to take the new data, and then you need to retrain your model because of the new customers purchase patterns are different. You need to retrain your model because your model was not up to date in terms of the data whatever you trained. Okay, in order to keep your model up to date, it requires a retraining. You understood? And what are the other scenarios? My model needs to be retrained. So there are scenarios. Let's say you have included some new features, additional features in your data set, additional columns in your data set. So in that kind of situation, you need to do the pre-processing and then feature engineering and feature selection. Again, you need to choose the different models and train those models and then tune the model, evaluate them. That is the reason why my machine learning models are iterative. There are various scenarios where you will end up retraining the model. If the model performance decays, you need to find out why the model performs. Is it because of the new data coming in, or is it because the new features that we integrated or included in our data set, or is it because of market drivers or political drivers, right? For example, in India, so a few years back we were using VAT system, the tax, right? So now, okay, so now what happened? GST, right? So again, the percentage, everything, the data itself changes, right? So this kind of situation, GST, and again, right, the state's tax and central tax. Likewise, right, you have different kind of things comes into picture, right? Policy changes leads to some changes to your data set. So those kind of situation you need to improve. So let's say, you with everything is good, but still my model performance is not good. So again, what you do is you try with a different data set and try with the different models and retrain the model and do the hyper parameter tuning everything and then you do it. Okay, there is a good question from Akshay Rao. Akshay Rao is asking this question: should the model be retrained when there is a biases? Okay, what do you mean by biases here? What do you mean by biases? See, that is what we need to make sure that there should not be any bias in our model prediction. Okay, there is a separate topic. Okay, our model should generalize very well. Like I said here, look here, I just go back to the previous example. Anyhow, if I explain that bias, you will get confused at this moment. So, right, probably we will discuss that in detail later point in time. Okay, it's not the right time to discuss about the bias. Okay, bias is a different topic. Okay, that we'll discuss it later. That requires too much of explanation. You will be bored because you are completely new into the machine learning and artificial and everything, right? Okay, we'll discuss it later. So this is what machine learning life cycle is involved. These are the stages involved as part of your machine learning life cycle. And I gave you the justification why machine learning model is iterative. Okay. The reason why it was iterative was the data and model refinement. Any new data comes in, you need to retrain your model. In case of sometimes what will happen is the model new data did not come, the data remains same, but what happens still you could see some kind of decay in your model performance. Maybe in that kind of situation, you need to take the production model to your development environment, and then you need to do the hyperparameter tuning, and then you need to check the model performance, and then you need to redeploy it. And we have something else called model drift and concept drift. That I will discuss it later. Okay, model drift, concept drift. That I will discuss because if I discuss everything in the very first session, you will be overwhelmed. Okay, that I will discuss it later. Okay, the next one is the tools. What tools that we'll be using it in each stage of the machine learning life cycle. That is the one we will take a look at it now. I just go here. So this is a machine learning life cycle. That's what we discussed a while back. As part of problem definition, we have something called Jira or Confluence. These are the tools you can use it to do to define your problem statement. Problem is something like I want to predict the customer churn, or I want to predict the housing price, or I want to predict the demand for specific products. Okay, so in that kind of situation, right, we use some tools to define the problem statement in a structured way. So what problem are we going to solve by developing this model with quantification? We are going to define it here. Okay, and then once you are using this tool, you define the problem, and the next one is you have something else called the Power BI tool. Power BI tool, right, it's a reporting tool using which you explore the data to gain insight. To gain insight. The simple example is when whenever I introduce any special offer, I could see a increase in spike in sales. Okay, whenever I introduce and again I could see a trend or pattern that when the demand is more, even though I increase the prices slightly for the high demand products, still we are able to sell. Okay, this is how the pattern we can see it. You don't have to, reduce the price all the time. Demand and supply, right? The supply is not there, hence the demand, but the demand is more. And the, right, in that kind of situation, even if you slightly increase the price, that's the right time for you to uh, tap the market, right? So you can still make the profit. So likewise, you can gain insights by exploring the data using Power BI or Seaborn. Power BI is also, right, it's a, though it is a kind of a open source, right? They don't charge anything. Still, you have some limitations. You can use the open source, the Python open source packages like Pandas, Matplotlib, Seaborn to perform data analysis, all the things. You can use these tools. Next one is to pre-process the data. You can use Pandas, NumPy, Scikit-learn, PySpark. Okay, all these packages are available as a open source as part of your Python. And the next one is the feature engineering. Okay, in the feature engineering, like I said, right, to create the new features based on the existing features, right, you can use something like feature tools, Pandas, or Scikit-learn. Next one is the Scikit-learn, SHAP, Boruta, Mutual Information. These tools are the package that you can use to do the feature selection. Next one is model selection. You can do it using scikit-learn, TensorFlow, PyTorch. This is for model building and model selection. Also, you can use it. And then next one is track experiments. What do you mean by tracking experiments? Let's say you started with training your model using linear regression model. So, what is the model performance? And then what you do, right? You take the random forest machine learning model. You train your model with the historical data, and then you fine tune the model using the hyperparameters. You note down the model performance for that specific set of hyperparameters. And then next one is you try with the XGBoost model. The data set remains same, but you are using different models with the different, like different core models, right? So you try with different core models. Similarly, you try with different machine learning models to train the same data, use the same data to train the model. Whichever model outperforms, you take the model. But later point of there could be chances whichever model you considered this month as was an outperformed one, probably 6 months down the same model will not outperform, right? So if you wanted to refer it back in the past, what all the hyperparameters helped me to improve the accuracy, you want to see the history, you have something called MLflow tool is available. Which version of model, with which combination of hyperparameters my model performance improved. Okay, for that you can use the MLflow tool and weights and biases. There's another tool, Neptune.ai, using which you can track the experiments. Like GitHub, you track the code version, right? Similarly, model version you can track it using MLflow. Okay, and hyperparameter tuning, even for that there are different tools are available. Up to now, HyperOpt, RayTune, these are the different tools are available as part of to do the hyperparameter tuning. And then to track the data sets and models, you have something called DVC. To track your previous version, you'll be using the GitHub. To track the different version of the data sets and models, you can use data version control also. What is the difference between DVC and GitHub? In the case of GitHub, you cannot track the data version because it has a limitation. You cannot, you cannot check in huge volume of data because of limitation, space limitation. You cannot store the huge volume of data. DVC, you can store huge volume of data. It will help you to track your data sets and models. These are the tools that you can use it. And then model evaluation. What metrics can I use it to evaluate the model? In the case of classification model, you can check accuracy, precision, recall, FN score. These are the metrics that you can use it to evaluate your model performance. Okay. And the tools, scikit-learn, TensorFlow, MLflow, you can use it. And then to the app building, right? User interface. These are the tools that you can use it. Okay. And then the next one is the monitoring. What kind of tools can I use it to monitor my model performance? So these are the tools that you can use it. Prometheus plus Grafana for metrics monitoring. Model drift detection. What do you mean a model drift detection? the model's performance decay, if you wanted to monitor it, you can use Evidently AI, Y Labs, these tools you can use it. And automate retraining. This is a beautiful thing, right? Whenever new data comes in, identify the new data automatically and then retrain the model automatically so that there is no manual involvement, manual intervention here, right? You can use Apache Airflow to create pipelines, right? Automated pipelines so that, you can trigger this Airflow whenever new data comes in, it automatically detects the new data and then it will retrain it. For example, in the AWS, we have S3 bucket. Let's say, you are going to add a new data in the S3. So what it detects the data, right? Whenever new data comes in, automatically detects and then it will retrain it. Okay, my data is available in database or DBMS, Oracle SQL Server. You have something called CDC, change data capture, right? So using which you can automate that. In case of any new data comes to my table, okay, and automatically retrain my model, right? So everything is available. Cube flow pipelines, Apache Airflow. These are the tools that you can use it to your, or you can use it to automate the retraining. Hence, you can significantly save your deployment time. Okay, significantly save your deployment time. Okay, so these are the tools that are available. You should be aware, at least any one of the tools in any one of the, in these stages, each stages. Okay, this is very much important. Any questions so far? Okay, you have understood what is machine learning is all about, and then we proceeded with exploring the machine learning life cycle, and then we discussed about um, the tools that are available in each stages of the machine learning life cycle. Yeah, we have almost completed 1 hour time now. So what we do is we'll resume the session day after tomorrow. And going forward, what we'll do is we'll have one day the demo session, the theory, and next day we'll have the hands-on. So when we do the hands-on, whatever you are not able to understand during the theory session, right? When you attend the demo session, the hands-on session, that will help you to solidify your understanding about the concepts, whatever I teach you in the previous session. Okay, that's how we'll plan it. All right. Any questions so far? So all right. Since you don't have any questions, I'm going to wrap up the session. Yes, I'm recording it. We'll share the recording, and probably I will create the community, and then I will share it to you. Okay. Okay, guys. 1 second before we wrap up. 1 second. What I will do is. So what I will do is, right. So yeah, before we wrap up, the plan for next workshop. The next workshop, what we'll do is we will explore the MLOps life cycle. That is a little bit difficult for you to understand. Anyhow, I'll try to simplify the CANs concepts, as in a very intuitive way, and then we will proceed with the demo session. Right, we'll start with step by step how to deploy the model. First we'll see that the traditional or the conventionally, how do we, how in the industry, how do they deploy the model in the production system, that we will see it. And then we will proceed with exploring how do we implement the MLOps level 1 maturity in our deployment. So in the case of MLOps level 1, our focus is more on continuous training. Okay, how do we uh, enable continuous retraining? That is the one we will set, and then we'll proceed with MLOps level 2. It involves a lot of steps that we will explore it step by step, because if I show it everything in one step, you will get confused. First, we'll start with understanding Git, right? What is Git and what is GitHub, and how to do the version control, everything. and then how do we create branches, and how do we merge those branches with the main branch. Okay, how do we resolve the conflict? Everything will go step by step. Okay, fine. So that is what we are planning to do that. And guys, what we do is to take this to the next level. Okay, for example, right, you wanted to you are very serious, you want to complete the machine learning model, sorry, the MLOps training in the shorter duration, and at the same time you want to get placement support, and also write resume preparation, everything our team will do it. If you want to take this to the next level, you can probably enroll for our course. Okay, we have two more guys are available. Even they have experience with Google Cloud and Azure. Okay, so what we do is here we are going to cover many tools. For example, how to deploy the model on SageMaker, AWS EMR, how do we deploy the model? Okay, the real world scenario, right? AWS EMR, we create the cluster, we use the Spark, right, to enable in-memory everything. How to to create various pipelines using various tools like Apache Airflow, and in the case of CI/CD, GitLabs, Git Actions, all the things comprehensively we try to cover so that there is no stone left unturned. When you attend for the interview, definitely you'll be in a position to clear the interview. Okay. So if you are serious about mastering MLOps and want to accelerate your career, I want you to join our comprehensive paid MLOps training program. It is up to you. Okay. And what benefit you will get, you can make a call to us during our daytime. Okay. To clarify your doubts and get personalized guidance. And other thing is you can gain real world experience by working with the industry level industry experts. Okay, we will connect you with our other MLOps guys. Okay, and also you will get in-depth study materials, best practices, and expert strategies, and importantly, the placement. Okay, we have a almost 85 to 90% track record, and we include only the 12 members per batch. We don't put more number of people because we want to give more focus or attention to these each members. Okay, hence we don't put so many participants as part of each batch. And interview preparation, everything we will give you before we share your profile with the potential customers or the employers, and then we'll help you to get placed. Okay, after completion of the training program. End of the day, you should also work hard in tandem with whatever the topics that we cover it. Okay. Okay, if you are interested, right, you can let us know. What we are doing is there is a separate batch going on. Based on your convenient time, if you let us know, right, we will plan the batch accordingly. Already 7 people they confirmed it. Okay, in the previous workshop. Okay, and 7 people they already enrolled for the course, and seven we are left with only 5 more slots. If you are interested, you let us know, we will include you as part of that. Okay, but still we will continue the workshops. Okay, and you see how it goes, right? Day after tomorrow we'll be continuing the next topics, and you see how it goes, right? And then if you are interested, you let us know. Okay, and this is what our website, I just show you here the website. One second, you can probably note it down. The course fee is and 4.9. Since those of you attended this demo session, there is a significant offer going on, discount. Okay, significant discount is going on here. So if you go to this URL here, training.deepneuron.in, here you will find that link here. You can just use your QR code to make the payment if you are interested, and if you are serious, and if you want to get the any doubts clarified over the phone, that is also possible. Okay, though that kind of benefits you can get it here. Okay, I'll just share this link, and here the QR code will be there. So you know you have in INR currency, right, so 9,999. Okay, the US dollar is, it comes around almost $120. Okay, $120. And again, two more MLOps engineers are there. They are also working in the real-time projects. You will get their experience also. They will also share their real-time use cases. We'll be working on some real-time projects also. Okay. So this is our QR code. This is the link wherein you can go here, training.deepneuron.in payment link, this way. Okay, this is for MLOps. We'll cover MLOps, everything. Okay, and it's going to be a almost 12 weeks program. 12 weeks program. So after, right, so just 1 week before completion of this training program, we'll start prepare your profile, and then we will conduct some assessment test you. Okay. Oh, Deepthi, you made partial payment, right? Okay, okay. She made 50 percentage now. Very good. Okay, fine. So we will create a community, WhatsApp community, right? So good that, right? So we will include you as part of our daytime batch. Okay. So now we have 8 members are there in that batch. And then you guys can decide and then make the payment here. Once you make the payment, you share the screenshot to this WhatsApp number. You can see the WhatsApp number, right? 843-843-5476. You can share your screenshot to this number. What we'll do is we will create login credentials, everything. Okay. Priya, okay, I made the partial payment of 4,999. Very good. Okay, fine. All right. Fine, guys. Anybody has any thoughts? It's up to you. Okay, I will leave it to you. You take your time and then you decide. Okay, so that we can put you in our ongoing new batch. And again, the workshop will continue. Don't worry. Okay, fine. Fine, guys. See you in the next workshop series. That is that we call it as a workshop series 2. So wherein we will see the MLOps life cycle in detail. Okay. Any questions? Okay, since you don't have any questions, I'm going to wrap up the session now.